Hello everybody, and welcome to this web demo. Thank you for joining that. My name is Ioannis Zotos, and in the next 1 hour I'm going to present briefly the calculations, what kind of calculations you can do with shafts and bearings in KISSsoft. So starting, I'm just going to show you a couple of things, what will be covered today. I'm going to show you briefly the shaft editor, so how you can edit and import geometrical and loading properties for a shaft calculation. I'm going to talk briefly about the strength analysis inside KISSsoft, about different ways of calculating bearing life, and show some practical examples in there. Just to mention, so we have a better workflow during this web demo. You're free to send any questions you like, but I will answer them at the end of the session. Yeah, some of them I will answer at the end of the session. If there is not enough time, I will definitely write back to you with an answer to your question. So let's start by opening KISSsoft. Most of the things I'm going to show you today are based on current examples of KISSsoft. So if you have a test license of KISSsoft, you can also follow these examples, or you can play with them whenever you want, whenever you feel like that. So I just open what is example 1 in our case. Here you can see how the whole shaft calculation user interface looks like. So on our left side here we have what is called an elements tree, where you see a tree of all the elements that are into your shaft. You can either expand and collapse the elements that are there, or you can see if you want to see all elements or only geometrical elements, force elements, or bearing elements, and so on and so forth. On the other side, there is what is called an element box. So when you define a shaft, you can just pick elements from here and drag and drop them to your shaft calculation. So for example, I can just drag and drop, I can just select a force and apply that to my shaft, position it where I want, and change its properties. So this element box is used when you want to add new elements to one of your shaft models. When you click on any of these elements, either on the tree or on this graphical representation, an editor of the specific element opens, where you can set up different properties of this element. So I have clicked now on a gear, and you say here you can see what kind of inputs are really important from a gear point to the shaft calculation. So you can really enter any of your data that you want through this process. The same holds for bearings or for geometrical elements and so on. So these are the basic modeling inputs, let's say in the shaft calculation. There are also other inputs that you can use. These are grouped into this basic data tab, where, for example, you can select if you want to consider your beam model to be a Timoshenko beam or an Euler-Bernoulli beam. You can set up different inputs for your lubricant or for your load spectrum. I'm going to show you that later on. So you can set up different modeling parameters like temperatures that are valid throughout the whole model, and you can define them here. So in the shaft editor, you set up your geometry, loads, and supports of your shaft, and in the basic data you just set up some general calculation settings for your shaft calculation model. As we saw here, we can define some supports for our shaft, and there are different kinds of supports we can define in KISSsoft. Once in this model, you see that we can define some rolling element bearings. there are different type of rolling element bearings we can define. So we can move through them and select the one we like, and then depending on the type of bearing we select, we can select a specific bearing from a bearing manufacturer based on the database that comes with KISSsoft. So we can select the bearing type and then a specific bearing from the database with all its parameters in there. Apart from rolling element bearings, another type of support that you can apply in KISSsoft soft calculation is what we call a general support. So this is shown like that. This is a more general way to define your boundary conditions, since you can define different boundary conditions per degree of freedom, and that way you can have whatever kind of boundary conditions you want in any position of your shaft. Just to show you how it looks like, there are different kinds of inputs you can have here, either non-locating or fixed bearing or fixed in any of both of the two sides, left and right. I just select the own input here so you can see how we can define boundary conditions per degree of freedom using this kind of support. So the support there can either be fixed, so fixed degree of freedom in this specific direction. It can be free. You can have a fixed width stiffness, or you can define a constant stiffness in this specific direction. Or we can have some initial offset defined using this kind of support. In this support and also in rolling element bearings, we can define how axial loads are going to be carried from this boundary condition. So, for example, we can say in which direction this bearing can support axial loads, either in both directions, either from one side or from the other side. So, for example, here we can see with this small drawing here that this bearing, the way it is modeled now, can take only axial loads from left to right. Another type of support we can have in KISSsoft soft calculation is a general bearing support. Here we can define the basic loading properties of this general bearing, meaning this attitude angle, the clearance, and the stiffness and damping values. What you should take into account when you use this bearing is that the values that you set here are kept constant when you do some dynamic analysis, for example. They are not updated. So you can use the constant stiffness and damping calculated from the standard and use this type of bearing as a support in your shaft calculation. Talking about supports, another really important thing we should mention is for rolling element bearings is how you take into account the stiffness of the bearings. So I have another example here. This is also one of the examples coming with KISSsoft. You see we have a case of many angular contact ball bearings, one next to the other. This could be, for example, a high-speed rotating spindle or any application like that. So I just opened this example to show you how important it is to take into account.
Muted. Unmuted.
How important it is to take into account correctly the bearing stiffness when calculating shafts into KISSsoft. So there are two different ways of using a rolling element bearing or modeling a rolling element bearing in KISSsoft. One is using the classical calculation, where I'm going to come back to that when talking about the bearing lifetime. But for the bearing stiffness point of view, this is assuming that your bearing has an infinitely stiff it has infinite stiffness. Sorry. There is another option where you calculating the life and the stiffness from inner geometry. So you're using the inner geometry of your bearing to calculate the real nonlinear stiffness of the bearing. In this case, while solving statically the shaft, you actually take into account the correct stiffness of your bearing. So let's see how this affects the results. I just selected now to calculate with infinitely stiff bearings. Just press this button and calculate results. If I go to the graphics, I can see how my shaft is bending in this case. So we see that the bending line really passes through the center of all bearings because the bearings have an infinite stiffness. If I go back now and change this setting to inner geometry and also keep this curve just for comparison, you will see now this new line here that our shaft now is not passing through the middle of these bearings. There is a correct tilting through the bearings. So this second calculation is much more realistic than the first one. So it is always proposed to use the inner geometry calculation for the bearing stiffness when doing the shaft, when using the shaft calculation in KISSsoft. So we saw some simple examples of shafts. There are cases where you would like to model something more complicated, or for example, you would like to use your a DXF drawing that you have already in order to be based on that and draw your shaft. So I'm going to show you how you can do that using KISSsoft. So I'll start a new shaft calculation for that. And I just have prepared a DXF drawing. You can import your DXF as a background into KISSsoft. Like that. And let's suppose we want to model this shaft into KISSsoft. There is a very easy way to do that. Since we have this DXF as a background here, we can just start adding some cylinders that will form the geometry of this shaft, and then just change the size of these cylinders dynamically with the mouse. That way you can start really modeling the shaft using the geometry that is in the background in the DXF. Of course, after you have your initial geometry like that, you can click on each of these elements and then start importing the real length and diameter that you have in your real drawing. But this can be an easy way how you can use a DXF in the background and really model a shaft from there. From time to time we have requests from some of our customers why we don't really import a full step model and then just recognize the 3D geometry, and so somebody doesn't have to really model something into KISSsoft. He can use just the 3D geometry from a step file. The reason why we have decided not to go in this direction is that when you have a step file as a 3D model, you always have there also some notch effects like shoulders or keyways or things like that. And this would make the whole automatic recognition process quite complicated and error prone. And we think that selecting the correct notch effects would be really a task for the designer to do, and not for the software to do. So have decided that it would be better if the user is responsible of entering the correct notch effects in the shaft calculation and not rely on automatic recognition of notch effects from a 3D step model. Talking about nodes effects, I will go back to our initial example so I can start talking about the strength calculation in KISSsoft. So this is the example I showed you before. Let's say we have modeled everything, we have selected our bearings, we have defined our forces, and then we just want to find all the critical sections on this shaft. We have to perform a calculation first, and then we can right click on the cross sections here and then ask KISSsoft to set which are the critical cross sections in this model. Then automatically KISSsoft selects the cross sections that are more critical from a strength point of view and enters them as cross sections here. Like that, you can see, for example, that cross section AA is a keyway, and KISSsoft has selected this one as one of the critical sections from a strength point of view. So you can see all the different cross sections defined here. You can see that BB is a shoulder. The same holds for CC and TD. So KISSsoft has selected the critical cross sections for strength based on your geometry inputs here. That is, of course, is not the only way you can define a cross section where you want to calculate specifically the strength. There is also a way to add a free cross section, so a user-defined cross section that you can place in any location you want, and then you can define the notch factors for the different loading conditions. Something like that could be, for example, useful when you would like to combine two different notch effects using equations from the standard. Or, for example, if you have some finite element analysis and you have calculated some notch factors from there and you would like to apply the same notch factors into your shaft calculation into KISSsoft. So you can freely define cross sections into your shaft and then define any notch factors that you want on them. So having defined all our cross sections and any kind of other inputs we want, we can calculate, and then we get some initial results into this results window, where we can see, for example, the maximum deflection or the equivalent stress. We can see the safeties for each of the cross sections defined. So for all the automatically defined cross sections from KISSsoft and also for the cross sections that we define, we can see the safeties. We can see the utilization with respect to strength for each of these sections. And we can also see bearing lifetimes and bearing reaction forces. I will not talk more about bearing lifetime here because I will talk about that later. So let's concentrate on strength for the moment. If this kind of information is not enough, or if you would like to go into more detail into the results, there is always this button. You open the report that comes with KISSsoft. There are different kind of reports. You can get different information. This is a general report where you have all the inputs and outputs on the shaft, and you have very detailed information about results that were calculated, not only strength but also deflections and stiffness from the bearings and some plots and everything. So you can get really to look into the results of the shaft through the report of KISSsoft. This holds for every KISSsoft calculation. Another useful thing that you can use to look into the results is using graphics. So for example, there is a special graphic for strength. Here you can see the utilization, meaning how much of the possible available strength in this specific point is used with the current load. So you can see in a graphic view all your cross sections, the position of all your cross sections on the shaft, and how much is the utilization on each of them. Of course, there are many different plots in there. For example, there is a displacement plot that we saw already, showing you displacement in every direction. There is also a force diagram, so showing you how the forces are distributed throughout the length of the shaft. And what I find quite useful is a 3D display of the shaft, where you can really see how the shaft is loaded, where the loads are applied, where there are bearing reaction forces, and you can also see how the whole thing is bending. I will just increase the scaling here so we see it a bit better. So you see here how the shaft tends to bend with respect to this bearing. We can also see how the shaft tends to twist following this twist line here. So with this 3D view, we can have a really good look into the different results. And maybe for this kind of simple shafts, it's quite straightforward. But you can imagine what happens if you are going to more complicated shafts. Then this 3D view is really helpful to get a feeling of how your shaft is bending and how it behaves under the load that you have specified. Okay, so this is what I would like to say about strength calculation for the moment. Let's move on to the bearings. Before I go into KISSsoft and talk about bearing lifetime calculation, I would just like to define some terms that we use and that are commonly used. For the bearing lifetime calculation, is one thing is calculated is a static load capacity following the ISO 76. Regarding the dynamic capacity, so the bearing lifetime, there are two different ways to calculate that. One is with using the ISO 281. This is what is called the classical method. This is the method used in the bearing catalogs from bearing manufacturers. So we're using this well-known CNC zero values and the equivalent loads, and then calculate life from there. There is also another way of calculating bearing life using the ISO 16281. This is using the real inner geometry of the bearing to calculate the bearing life. In both cases, we have also what is called the modified life, where there are some modification factors in the calculated life, take into account, for example, impurities in the lubricant or any other kind of non-normal, let's say, or non-basic operating conditions. So this is the terminology that is also followed in KISSsoft, and you can see this this designation here into the KISSsoft results window and into reports and everything. So having talked about that, let's go back to KISSsoft. As I said, using the inner geometry bearing calculation, the inner geometry of the bearing has to be known. This is not an easy thing to do. This is not an easy piece of data to find. So KISSsoft is helping you there using some kind of reverse engineering method, starting from the CNC zero values defined in the bearing catalogs. We work backwards and find the inner geometry data that would result in these CNC zero values. This is not just a magic that KISSsoft is doing. This is something documented in the standard, well documented in the standard. So it's a well-defined procedure to do that. And KISSsoft is using this in order to find the basic inner geometry properties of the bearings. Of course, it's always proposed to use real inner geometry, or to ask your bearing manufacturer for real inner geometry data whenever you have a really critical or a critical application with respect to bearing lifetime. So if you have very high speeds where, for example, the caging would come into play for the bearing lifetime. So when you have some extreme cases, it's always better to ask your bearing manufacturer for exact inner geometry data, and also ask them for help calculating the bearing lifetime. KISSsoft can give you, even in these cases, a very good result that you can be based on, but it's always better to have the real inner geometry data for critical applications. So let's see what we get in the results window for a bearing lifetime. So I just perform the life calculation again. So we get the service life for all bearings in the model, and we are using this designation I told you about. So M is the modified life, take into account the modification factors that are defined in standards or in bearing catalogs. Also, again, in the report, you can get more information regarding this this bearing lifetime calculation. What, of course, is quite important when we're talking about life is are the load spectra, because, of course, one shaft does not rotate in a constant speed throughout time, but the whole speed may change and the load may change, and load spectra play a big role, an important role into the bearing lifetime calculation in general, in the life calculation of the shaft. For that, you have to define your load spectra in your load elements. What you should always take into account is you have a perfect torque balance for each load bin in your load spectrum. So, for example, here we have two load elements, one coupling and one cylindrical gear. For them, you can go and define in the element editor what kind of load spectrum you want to define. We have some predefined load spectra for you, quite a lot of them based on standards. And we also have, the user can also define its own load spectrum based on measurements or any kind of data that is available on their side. So we define one load spectrum as an input in one of our force elements in this case, and then we have to define the same load spectrum as an output in the gear in this case. In such a case, we should make sure that here we consider load spectra in our calculations. So in basic data is whatever has to do with the basic settings of our calculation. So if I calculate now, the whole thing is calculating the KISSsoft is calculating the whole load spectrum, and you can get results in your results window in your report again per load spectrum and as a total value. So you can get the life out of there. So this is how you can also include load spectra there. Looking at this window now, I saw this oil level also here. This is something I didn't mention before. So you can define how high is your oil level into your shaft calculation, and based on that, you can KISSsoft can calculate correct factors for your bearing life and your lubrication in your calculation. There are a couple of other things that are quite useful from KISSsoft. One of them is that KISSsoft can make a sizing of the shaft for you. So after you have defined a shaft, you can ask KISSsoft to propose a different design for the current loading on your shaft. So I will just open again this example from scratch. So we can forget about all the load spectra for now. We can just have one load, and we want to calculate. We have defined a basic geometry, how we want it to be. And we want KISSsoft to help us validate that this geometry is the optimum one, or if there are some steps we can do to optimize the whole geometry. There are two different ways we can do that in KISSsoft. One is by right-clicking on our shaft. There is this sizing functionality. We can either size for strength or for deflection. So there are some basic user-defined settings where we define a maximum equivalent stress for our shaft or a maximum allowed displacement, deformation. And then based on this value, KISSsoft can size our shaft either to reach the maximum stress or to reach the maximum deflection. So if I select the sizing for strength here, KISSsoft is proposing this kind of shape that would result in the maximum stress utilization from the shaft. Of course, we see that this kind of shape is not something that we can use for a shaft, but this can give us an idea of how or where is the area where you could remove some of the material and still the shaft will be able to hold the static load that we apply to them. If we go and size for deflection, we see that we take a different geometry here, defining that KISSsoft has calculated that you can remove all this material here if the only thing that matters for you is the maximum deflection. Comparing these two lines, of course, we have to take the maximum, the highest one, the highest diameter, because, for example, in this area, if we go in this diameter, then we still are within our maximum deflection, but the stress will be much higher. Another way we can do that, instead of just having these lines there, is using this rough sizing functionality. So after you have defined the basic properties of the shaft, we can go in here and ask for KISSsoft to provide different or the optimum real design. So really model the shaft and not just show some proposed lines, really model a new shaft, take into account our highest stress and really changing diameters of geometrical elements, location of gears, of bearings, type of bearings. So KISSsoft can really start designing the whole thing based on the input loads and propose us the optimum solution. I will just use the defaults here just to show you what this thing can do. So it's doing some iterations, tries many different possible solutions for this problem. And then KISSsoft comes with a new design. We can see here with the red line is the initial geometry we had. And we can see that the cylinders have changed. And this is the new optimum design proposed by KISSsoft for this specific maximum stress. This can be more advanced. We can also ask, as I said, for new bearing types or new bearing locations, so we can get a completely different shaft design in the end. Of course, this would only take into account stresses. As you all know, there are many more things that you should take into account when you design a shaft, but anyway, this can give you some other views of how your shaft would look like. Talking about strength, again, since I mentioned that you have to take into account the highest stresses and when calculating strength, I forgot to tell you about the different calculation methods that are available inside KISSsoft for calculating strength. So the methods that can be used are based on different standards, from DIN to AGMA, FKM, and many different other things. And we can either calculate strength defining a required service life, so we can calculate stress based on a limited life strength, or for an infinite strength. Depending on the method that we select to use, there are different inputs necessary. All these inputs are defined in the respective standard, where the user should refer to and input the correct values for his application in there. And we can also define how the shaft is loaded, how is the cyclic load applied on a shaft in every direction. All these things are really important when designing a shaft for strength, and KISSsoft can really cover all the important standard calculations for strength calculation of shafts. So in the beginning I said that I'm going to show you also some other more complicated models that you can use KISSsoft to model. I'm going to show you some of them now. So apart from these simple models that we saw up to now, we can also model in KISSsoft, for example. Let's just make the whole screen a bit bigger for you. We can model a full planet carrier, where we see here we have the three shafts that build the whole planet carrier model. We can go and see a DCD transmission, or we see we have two shafts in this case, and we have load elements on each of these shafts and how they are connected. Or we can go to even more complicated models, like this transmission, where you see we have so many shafts in here, and you see that as the model gets more complicated, all these tools that I mentioned before are becoming more and more important for the designer. Here we can see that modeling coaxial shafts, as in this case, we have to define also connecting bearings. The connecting bearings have the same properties, or can be of the same type as the bearing supports. So they can be rolling element bearings, general supports, or sliding bearings. And for rolling element bearings, whatever I told you about about using the bearings as boundary conditions as supports holds also for the case of using the rolling element bearings as connections. So we can again have inner geometry calculation or classical calculation for rolling element bearings. We can also use general connections similar to general supports, so we can define boundary conditions per degree of freedom for connecting elements between shafts. That way, for example, we can set up shifting transmissions, so we can select in which direction the power flow goes by selecting to have a fixed rotation around the y-axis, or a fixed shaft rotation. So the two shafts should rotate at the same time for any of the shafts in the model. So these connecting elements are the only new element adding on complexity of shafts, of coaxial shafts, into KISSsoft shaft calculations. At this moment, since I would like also to have some time for questions, I will not go to vibrations, since vibrations is a quite broad subject, and that was covered in another web demo. I will just refer you to this other web demo that you can find in our website under trainings and web demos. There you can see a very detailed demo of how you can model vibrations into shaft calculation of KISSsoft. Just to mention, KISSsoft can calculate eigenfrequencies, eigenmodes, and forced response due to unbalanced mass in its dynamic calculation, and it can also calculate buckling in there. I'm not going into this direction now. I just want to stop here. Just wanted to mention that if I managed to trigger your curiosity, I would like to invite you to one of our shafts and bearings trainings. If you want to hear something more about shafts and bearings, the next training will be on the 5th and 6th of March. There are still places available there, and I will be really happy to welcome you here in Bubicon, and we can go deeper into the shaft calculation together. And also, I should not forget that hangouts of this web demo, together with licenses necessary to run all these details, can be found in the downloads of the demo. So let me check the questions that you sent, so I can ask some of them now. Yeah, so one of the questions is if we can define a preload in the tapered roller bearings. Actually, there are different ways we can define a preload into KISSsoft. You can either define a preload by setting an initial offset in your bearing, or you can define a preload by making your tapered roller bearing a connecting bearing and applying a stiffness, so in order to model a spring that applies a preload into your tapered roller bearing, you can model it as a connecting bearing and apply a stiffness on one of the shafts that connects to the tapered roller bearing. So I guess that maybe this quick answer may be not enough for this kind of question, but these things are covered in more detail into the trainings. But a quick question is, you can have preload on your tapered roller bearings, and you can either have a predefined displacement as a preload. So if you modeling what you have when you use seams into your assembly, or you can also define a preload using a spring or a stiffness. So what happens when you have a spring into your assembly, into your real assembly? Let's see other questions. There is another question if the outer ring of the bearings inside KISSsoft are considered rigid. The question is yes. So whatever goes after the outer ring is rigid for KISSsoft. This is where we make the cut for our free body, as we used to say in the university. So this is where our world stops, and then everything is rigid after that. But on the other hand, KISSsoft can really model cases where what comes after the outer ring is not rigid. This can be done, for example, if you model your support as a connecting element and your outer shaft is your environment, then you can apply a specific stiffness on the outer ring. Or if you come from KISSes, you can really use the full stiffness matrix of a complete housing into your KISSes calculations, and then the shaft calculation of KISSsoft will take into account the correct stiffness of the housing that is around the outer ring of your bearings. So let me have one more quick look. Let's answer one more question. I saw you in my presentation. You maybe saw that when I opened the available bearing types, there were bearings from SKF there. This doesn't mean that we only have SKF bearings. We have many bearing manufacturers, FAG, Koyo, and many others. Timken is in there. So all the big bearing manufacturers are in there, and also a lot of small ones. And of course, the database of KISSsoft can be extended by the users. So if the bearings that we provide do not cover all your needs, you can enter your own bearings in the database and use your own database entries out of that. So yeah, I think that that was for now. If there is any question that you would like to be covered and it was not covered now, just please send an email and I will write back to you. Thank you very much for attending this web demo. I hope that I managed to give a good overview of what KISSsoft can do in this respect, and I triggered your curiosity so you want to learn more. So thank you so much, and have a nice afternoon or have a good day depending on your time zone. Thank you so much. Bye bye. Bye. Thank you.